Apollo sample 10044, lunar basalt, a piece of the moon that an astronaut picked up and placed in a box half a century ago. It is 4.5 billion years old. It should belong to another world. But chemically, it does not. Its isotopes read like the Earth. Every rock in the solar system carries a chemical fingerprint. Mars, Vesta, the carbonaceous asteroids, all distinct. Each body is unique. Take a meteorite from any of them, and a geochemist can tell you where it formed, isotope by isotope. Then there is the moon. The moon's entire isotopic fingerprint matches Earth's mantle. Not similar, matched. That is a problem planetary scientists cannot close. The leading theory, the giant impact hypothesis, says that 4.5 billion years ago, a Mars-sized planet called Theia struck the proto-Earth. The collision vaporized both worlds, and from the orbiting debris, the moon coalesced. The theory explains the moon's size, its small iron core, the tilt of its orbit. But it makes a prediction. As the moon formed mostly from Theia's shredded remains, it should carry Theia's isotopic signature. It should look chemically alien, like a sample from a completely different body. It does not. When we check the evidence on sample 10044, we see the same thing we see in every other Apollo sample: oxygen isotopes, titanium isotopes, silicon, chromium, tungsten. Across 5 different elements, the moon and Earth are nearly identical. A PMC study on vanadium isotopes made it formal. The offsets are so precise that they break every standard collision model. Scientists have a name for this. They call it the isotope crisis. It is not an exaggeration. It is an open exhibit in a cold case. The first suspect was a more violent collision. In 2023, a paper in Nature Communications, Earth and Environment argued that only a Synestia could produce the match. A Synestia is a rapidly rotating donut of vaporized rock that forms when 2 planets collide with extremely high energy. Inside that structure, material from both bodies mixes so thoroughly that the isotopic signatures are erased. Only then, as the Synestia cools, does the moon condense out of the blended debris. It would look like Earth because it is Earth and Theia stirred together. The model requires an impact so energetic that it pushes physics to the limit. It is a possible explanation, but it is not universally accepted. And when we look again at sample 10044, we must ask, was this rock forged inside a rotating vapor donut? The evidence is still under review. A second line of investigation looked not at the collision violence but at Theia itself. In 2024, a study published in Science used isotopic fingerprinting to trace Theia's origin. The results pointed inward. Theia appeared to have formed an inner solar system, the same neighborhood as Earth. If that were true, then Theia and proto-Earth might have been chemically similar from the start. They were siblings. In that scenario, the moon's Earth-like isotopes are not from mixing during the crash. They are because the impactor was always made of the same stuff. This is a cleaner hypothesis. But it shifts the question. If the inner solar system was chemically homogeneous enough to make 2 identical planets, why are all the other inner solar system bodies we can measure, like Mars, different? The model expects uniformity that we don't see anywhere else. The suspect has an alibi, but the alibi doesn't hold up under cross-examination. Then in April 2025, a preprint was posted on RxIV. It has not yet been peer-reviewed. Its proposal is entirely different. The idea is that proto-Earth was spinning differentially. This outer shell rotated faster than its interior. When Theia struck, the impact gouged material preferentially from that fast-spinning outer layer, which was made almost entirely of Earth's own mantle. The debris disk that formed the moon was overwhelmingly Earth material. The moon, in this model, is a chunk of the Earth's outer skin, thrown off by a grazing hit. The mechanism explains the isotopic match without requiring a Synestia or an identical twin for Theia, but it is new, it is not yet verified, and it disputes the other two proposals. 3 different models, 3 different mechanisms, none agrees. The isotope crisis remains open. The case file on sample 10044 is thick with theories. The lab work is rigorous. The isotope measurements are precise. The forensic consensus is not there. Meanwhile, the moon itself is moving. It recedes from Earth at 3.8 centimeters per year, not because of the impact, but because of tides. As it drifts outward, its apparent size in the sky shrinks. Right now, in this specific slice of Earth's 4 billion year history, the moon's angular diameter happens to match the sun's almost exactly. That is why total solar eclipses are possible. The disk of the moon covers the disk of the sun perfectly. In about 1 billion years, the distance will be too great. All eclipses will be partial. This is a temporary alignment. We happen to be alive in the only window when you can stand on Earth and watch the sun be completely blocked by an object that does not belong to this planet. The moon's far side, permanently tidally locked by tidal forces, will never swing into view. We are looking at a shared moment, and we still do not know how the object itself got here. Sample 10044 sits in a clean room. Its isotopes say Earth. The collision models say that should not happen. 3 active investigations are underway, each offering a different sequence of events, 4.5 billion years ago. All are plausible. None is settled. The evidence is physical, documented, and contradictory. This is not a mystery of missing data, it is a mystery of interpretation. The chemical fingerprint is unambiguous. The origin story is still incomplete. The moon is a witness that refuses to explain itself. And it is moving away while we ask the questions.